Hello, welcome back. My name is Victor, and in the last video we expanded binomials into trinomials. So by 2, try 3, 1, 2, 3. So we've expanded to 3, whatever this is. And so today what we're going to do is we're going to reverse this process. We're going to make them into 2 again. 2 binomials. So this is factorizing. This is probably going to be the single most important algebraic skill that you'll be using in year 10 and 11. This is very important, so important. Remember the pattern from the last video when we expanded x plus a times what? X plus b. What did we get? We would usually get a answer of x squared, and with the middle coefficient being a plus b times x, and then the constant was a times b. So when we need to factorize this, we need to reverse engineer. So we need to find the two numbers that add to give us the middle coefficient and multiply to give us the constant. So here's the new habit right here. Multiply to c. It's a little bit of course, hard to see, but as you can see here, right here, so multiply to c, add to b. Now let's go to the first example. Factorize x squared. Let's factorize x squared plus 5x plus 6, and let us use our t-chart here to systematically test factor pairs of 6. Let's do it very visually. Why are we doing this very visually? Because of course when in doubt we're going to draw it out. So what we're going to do is that we're going to find for numbers that test them out and test out the factor pairs of 6. So what I'm going to do is I'm going to check, of course, so to 1 and 6. So let's check 1 and 6 plus. So let's check with the first pair. So multiply to c, 1 and 6. 1 multiplies by 6 equals 6. Okay, that's the number that we're finding for. However, if we actually add 1 plus 7, 1 plus 6 here, it will give us 7. And we're not looking for this number. We're looking for 5. So first pair, 1, 6, that is out. That is out already. But let's go into our next pair. The next pair will be 2 to 3. Now why 2 to 3? Because these will multiply to become 6. Okay, now let's try it out. So 2 to 3, 2 times 3, they will equal to 6. Okay, pretty good so far. Now we need to add it to b, add them together. 2 plus 3 equals 5. Okay, that's our pair. That is our answer right there. So because we have found our pair, we just need to swap these values, like 2 to a and 3 to b, and what we will have our answer right there. So the answer would be 2 plus x plus 2 times x plus 3. Now of course when we do this process together, we're going to have to do what? We're going to have to check by expanding back. Now we know in the last video that x plus 2 times x plus 3, this will give us, this one right here. Yeah, so we know it's going to be a perfect match, of course. So but I want you guys to go to an even trickier one, because you don't want to keep doing the easy ones. Of course you do them multiple times, but at some point you're gonna do like the harder one. So let's go to the trickier one. So we have x squared minus 7x plus 10. Okay, so I'm finding for, again, we have our numbers here. We just need to find the coefficient of x that adds up into minus 7, because we have identified minus 7 is the number that's next to x, and then what's the constant? 10, just like that. And so we just need to find two couple of numbers that does this. So we need to try our very first pair that multiplies to what? it multiplies to 10, and then it adds up to -7. I need to find two members. Why? And both numbers here, it needs to be negative here. Why? Because negative times negative is positive. So this is the number. So some kind of negative numbers here. What kind of numbers that we're trying to look for? So let's try first our very first edge case. -1 and minus, and let's see, is it -1 and -7? Probably not, because this will add up to around -8 or so. So that's not what we're looking for. We need to look for something that will multiply up to 10. So we need to check first -1 and -10. Okay, and this is our first pair, so let's multiply together. -1 -10, this will give us 10. Okay, now will they add it to -7? And unfortunately not, because this will be all the way up to -11. That's too much. So we need to try our next pair. We'll try the next pair, which will be -2 and -5. Why? Because these numbers will multiply to 10. So let's try that right now. So we have -2, -5. Okay, that's great. That's good. Now we just need to add them together. -2 plus -5, and this will very fortunately land us -7. So right here, what we have is both conditions are met. We have -2 plus -5 equals -7. What we have here, the first condition, and the second condition will be -2 multiplied by -5 equals 10. That's our second condition. And so when we have these two values that have these two conditions, great, those are our values right away. And so when we factorize this, right, x squared minus 7x plus 10, we can immediately turn them into what? We can immediately turn them into, let's see, we'll have them as -5, factorize them into -2, and this will be our, this is not factorization, it's factorization, sorry. So this will be our factorization form. Okay, give it a little bit of time, and that should be it for our second example. So I'm going to the third example now. It's going to be a little bit trickier, of course. Our third example will be mixed signs. Most of these kinds of factorizations will be mixed signs, so it can be a little bit annoying, of course. So let's just draw now. So our a plus b should be 2, and our a multiplied by b is -15. If we apply this pattern and we do this again and again, we'll come up with the conclusion that these are the numbers that we just need to find. That's all. And so let's try it out. I forgot to do the check right here, but I'll do the check for this one. The last check should give you around it's the correct answer, and if you do like swap them, substitute them back, check by expanding back, you should have the same answers or so. But I'm going to check by expanding back the habits here for this particular one. Now the constant is negative 15. Now we need two numbers that multiply to -15 and add to +2. So for the product to be negative, the two numbers must have positive signs. So it can be one positive, one negative, or one negative, one positive. It doesn't matter with the position. So we just need to find these two that multiply up to -15. So let's check our very first edge case. We'll have -5 and 3. These will multiply up to 15, but when we actually add them together, -5 plus 3 it will give us -2. We're actually looking for 2, so let's just reverse them back a little bit. So we'll put this as 5 and -3. And so what we have is it multiplies to -15, of course. But when we actually put them into like this, we have 2, because this is the same as 5 minus 3 equals 2. Okay, so we have found our values. This condition is good because 5 minus 3 equals 2. This condition is also good because it multiplies into -15. Both numbers are mixed signs, one negative, one positive. That's all pretty good. So we have multiplied to C, add to B. That's done. We need to do our next habit, which is check by expanding back. So with x equals to 1, of course, I'm going to write it out. So I'm going to write out x squared plus 2x minus 15. This is our original example. When we put 1 here, we have 1 plus 2 minus 15, and this will give us -12. -12. Now we of course we want to factorize this, and then when we factorize this, what we have is we will have a, I think this is how it's written. So I think this is how it's written. I might be a little bit wrong here. It should be like this because it's 5x, and then yeah, so very sorry for that. I got the signs mixed up here. But this will be our factorization, because when we swap the values here together, we want some kind of form of x equals a into x equal b. We want to factorize this in some form kind of way, and so we just need to swap 5 here into a, because this is the value we found. 5 into a minus 3 into b. Now we need to swap 1 to the x here, so we need to swap. So 1 plus 5 and 1 minus 3, we will have 6 multiplied by -2, and this should give us -12. Okay, perfect. So both sides is equal to -12 when x is equals to 1. That's perfect. Okay, so we have our checks are correct. This is what we will write in our notes. Of course, we won't be writing this in our exam papers, but it's always good to give a double, triple check, something like that, when you're expanding or doing whatever. So we have done our second habit. That's great. So let's recap so far. Let's give you a quick decision framework for the signs. So if they, how would I say it? I would say if A is positive, for example, and B is positive, then A multiplied by B is going to be positive. Okay? Now I'm going to expand this a little bit more. This is going to be a little bit obvious, of course. Now if A is negative and B is negative, now two negatives will make one positive. This will create one positive. Now on the other hand, when we have one positive and one negative, this will create one negative number. It doesn't matter whether A is negative or B is negative here. In this case, if there's one negative and one positive, it's always going to be the negative number. So the bigger number is going to take the same sign as B. So this is just a little bit of a rule of thumb or so when you look at some of the these numbers that exist in these ends, in some of these examples, and that is what you can expect to learn. So let's recap just a little bit. Today's habit, we have multiply to C, add to B. Say it every time when you factorize. It's very important. This is going to be your checklist. There's no guessing, there's no forgetting. Multiply to C, add to B. Multiply to C, add to B. And always check by expanding back, or expanding back as in when you actually try to do the expansion yourself, or when you substitute a value. Substituting a value is also very useful in our cases when we want to write out notes and check whether our expansion or factorization is actually correct. Okay, and of course, when in doubt, draw it out. Very classic. And so in the next video, we will be using factorization to actually solve quadratic equations where the expression equals 0. What does it look like? It will look something like this. So we have x equals 3 times x minus 4, and it equals to 0. This will be pretty easy because we just need to say like, oh, each of them are 0, right? Each of them are 0, so because each of them are 0, x plus 3 will equal to 0, or x minus 4 will equal to 0. This is the easy part. The actual hard part is that you need to convert something into a form something like this, into 0, and that will be the main challenge. But I'll see you there in the next video. Thanks for watching.